Aloha and welcome to this screencast on template state communication in Meteor. That's kind of a complicated title for a fairly simple concept that I think many of you will run into when you're developing your Meteor applications. To understand what I mean by this, I think it's useful to take a second to talk about what we mean by state in Meteor in general. And I want to contrast two kinds of state information. I'm going to call one kind of state domain state, which is it has to do with your data model, and you typically want it to persist between sessions, like your username and password, or if you're building a list of contacts, then it would be an individual contact entry. Domain state, you basically always want to store in Mongo collections, because that's what Meteor's backend is at the moment, and that's good because Mongo collections are essentially a kind of global state in any Meteor application. So in any page or any template at all, you can always get at the backend Meteor collections, and if you update a Meteor collection in one template, that state gets automatically reflected in any other template that uses it. So domain state's really easy to deal with. There's another kind of state called what I'm going to call user interface state, and that state that does not persist between sessions and is not really essential to the domain. So for example, if you're on some page in your Meteor app and you highlight an element, that's state in a sense that has to be maintained, but you wouldn't want to put that into a backing Mongo collection. You wouldn't want to persist that in the database. So the question is, what do you do with that kind of state information and how do you manage it? And there's a few different ways to do that, but I'm going to show you what I think is a very simple and useful design pattern for dealing with this. But first, let's look a little bit more at this domain versus user interface state. And to illustrate it, I'm going to show you a mock-up of a application that we're working on. And on the left side of the screen, outlined in red, is an academic planner. So you might set up your courses, for your degree program. And whenever you click on one of these course names, like if you clicked here over ICS 311, what would show up on the right-hand side of the screen in a kind of an inspector window would be more detailed information about that particular course. And then if you went back and clicked on ICS 141 over here, then over in the inspector on the right side, you'd see that would be replaced by information about ICS 141. So so as I just said, clicking on a course in the degree plan on the red side brings up more details about that course in the right side in the inspector. So the academic plan constitutes domain state. This is something that you'd want to persist for each student or user. If the system crashed, then you wouldn't you'd want to be able to bring up the system and have that be preserved. On the other hand, if the system crashed and you lost, which course was actually selected, or you logged out of the system and logged back in, then of course you wouldn't want to, you wouldn't worry about losing that particular state. So this is an example of user interface state, what the currently selected or displayed course is in this right-hand window. Okay, so how could we implement this kind of system in Meteor? And the easy way is to simply say, okay, we're going to have a template, and inside that template we're going to render everything to do with the degree plan, and we're going to render everything to do with this inspector, and kind of like super easy, right? There's really no problems at all, because since you can simply have some local variable essentially that is transmitted back and forth between the whatever is selected and what should be displayed in the inspector window. The problem is, what if you had another page that's different from this one, but that needed the ability to inspect courses and opportunities and provide details on that? And in fact, in this particular application, we have other pages where we'd like to be able to list courses and opportunities and inspect them. Then we couldn't reuse that code within this template. We'd have to copy and paste it, because when you render it within a single template, these two things are going to be intimately bound together. So whereas you could always have a single template render all the contents of a page, that's kind of junk, right? Really, being budding software engineers, we'd like to be able to modularize things, be able to reuse code without having to cut and paste it. That can be a terrible source of errors. So the more natural approach here would be to say, okay, well, since this inspector thing could be reused in multiple places, why don't we have two different templates? But the problem there is that now we need some way for this template, when the user clicks on an item in this particular template, we need a way to communicate that state, what's the selected course in this template, over into this template in order for it to do an update. And obviously we don't want to basically have a Mongo collection that just stores the currently selected course to do this, because that's just kind of crazy, to be updating your backend database every time you select an element. It's inefficient and just inappropriate. There's got to be a better way. Fortunately, there is. So in general, the design problem is that if we have two or more Meteor templates on a single page, how can we communicate UI, user interface state, between them? So let's see how we do that. And the answer in a nutshell is that we're going to end up dividing our page into a set of templates. We're going to have one top level template. We're going to call this the page level template. And then within that page level template, we're going to render two or more component templates. Okay, so we have this idea of a top level page template and interior component templates, and why that distinction is important is because the page template is going to create a single reactive dictionary whenever that template is created, and that dictionary object is going to be passed as a parameter into all of the component templates. And then that reactive dictionary is going to constitute the channel, the communication channel for these individual component templates to communicate back and forth whatever they need to communicate. So in the case of our example, we'd have a reactive dictionary at the page level. It'd be passed into both our degree plan template and our inspector template, and then whenever someone clicks on a course in the degree plan template, that reactive dictionary would be updated with the new course, and then because the inspector template would see that change and re-render itself according to the new contents of that reactive dictionary, and things will work the way you want. So these component templates can use the Meteor invocation template.currentData to get at that dictionary, and then they can do the get and set methods on a reactive dictionary to communicate between each other. So that's how we're going to do it. Here's a more kind of graphical illustration. We'll have an outer page level template within which is rendered two component templates, and then the page template is responsible for having a single reactive dictionary. It gets passed into both of these component templates, and then they update that reactive dictionary as a way of communicating whatever it is they want to communicate back and forth. Okay, well that example of the course browser, that was a good example of what would motivate this situation. However, that code is really complicated. So I want to give you an example of the actual implementation, and in order to do that, I'm going to show you another application which enables the code to look really simple. Unfortunately, it doesn't really motivate the use of this template approach, and that's this system called Digits. And let me just switch to it. So here's a running version of Digits, and the idea is it's a little contact manager, and on this first page we have a table and then a little message bar beneath it saying how many entries have been created. And what I'm going to do for the purposes of example, even though it doesn't really make sense in practice, is I'm going to make two different templates, one template for the table, one template for this little message. They're going to communicate back and forth by a reactive dictionary for this entire page. Okay, and the reactive dictionary is important because when I, for example, add a contact, so I'll add, Joe Darn at Manoa Road, and their phone number is 808-956-0000, and their email is joe@darn.com, and we submit this. What we find is that our table has been updated, now has 5 contacts, and this underlying message has also been updated. So that's the reactive notion. The reactive nature of a reactive dict is that when we update our state information, everybody will re-render themselves, appropriately, and that's part of the magic of Meteor. Okay, so that's a little demo of kind of what this digit system actually does in the context of our example. Even though, if you're doing this in practice, it would be ridiculous to create 2 templates for that. In fact, it's ridiculous to have the creating 4 contacts, I'd say, but pedagogy. Okay, so one idea is to have a single page template for the whole thing. That's the more obvious approach, but what we're going to do to illustrate this design pattern is to have 2 component templates, one for the table, one for that little contact message. Let's see what the code looks like. We're using the standard Meteor Guides approach of having an imports directory, and then inside there a UI subdirectory, and inside there are components, layouts, and pages. So our page template for this example is implemented by the 2 files home-page.html and home-page.js. We have within that home page, we have a table and then a little message indicating the size, and so here are our 2 component templates consisting of these 4 files. And then, just to be complete, remember that our Digits application actually had a little screenshot or a little image at the top. It had a header, it had a footer. So in a real world Meteor application, you also have this outer layout level template, which is the stuff that's generally common across the entire application, and embedded, and all your different pages are embedded within a single layout or one or more layout templates. But the layout one is immaterial to this example, but I just want to let you know that there is one there in case you were wondering. So let's go through the code. How does it implement it? So to start, our outer page level template in this case is called homepage. Here's what the JavaScript looks like. We're going to import this reactive dict from Meteor reactive dict. You've got to do a Meteor add reactive dict to get this. It doesn't come by default. And then what we do is whenever this homepage template is created, we have a function that runs that assigns, creates a new reactive dictionary and then assigns it to a variable called this.homepage.dict, or assigns it to a field in the template instance. And then we create a helper function called home-page.dict, which returns the home-page.dict field of the template instance which was assigned there. Okay, it also subscribes to some context, but that's well. Let's look at what the HTML for home-page.html looks like. And basically we're going to invoke, we check to see if we're logged in, we check to see if subscriptions are ready, and then we invoke our 2 component templates. The first one being the table that we want to lay out. We pass our reactive dictionary, home-page.dict, as a parameter called parent-page-dictionary, and then we also pass the list of contacts which the table needs to render itself. For contacts.size, all we need to pass in is our reactive dictionary, and again we're going to assign it to this this parent-page.dict parameter. And the idea here is that in the case of the home page, we have a reactive dictionary called the home-page reactive dictionary, but from the perspective of these components, they're just asking for a dictionary from the parent page. They don't really know. Maybe they're rendered on some other page from the home page entirely as well. So by doing this, by the components referring to parent page dictionary, it makes it more explicit that they just care that whoever is above them, and it could be different pages, are passing in a reactive dictionary that's going to provide the information that they need. So let's look at the contacts-table.js, and here what you can see is that each time, remember, so it turns out in this example the responsibility of the contacts table component is to set the number of entries in that table in the reactive dictionary, and then the responsibility of the contact size component is to just find that value and then render it. Okay, so in the case of contacts table, what we're going to do is simply provide a function every time it's rendered, because every time the context table gets updated with a new number of elements, it's got to be re-rendered. So this is the kind of the appropriate place to update the reactive dictionary to indicate what the current number of entries in the table is. And to do that, we call template.currentData.parentPageDictionary. So we're getting at the reactive dictionary that was passed into us via the parent, and then we're going to set the count field in that reactive dictionary to the number of elements in the contacts collection. So that's a completely domain-specific thing about what you actually need to do to communicate back and forth. In this case, you're just communicating the number of elements that are being rendered in the table. If we look at contact size, here the idea is that we want to receive a reactive dictionary from the parent, and that reactive dictionary better have a field in it called count, which is the number of current entries in the table. And so we create a helper function called contacts-size that returns that value, and then that will be actually laid out in the page. So that's basically it. In conclusion, for domain state, you have one choice. It's easy. You're going to create Mongo collections, and that creates essentially global state that can be accessed from any page or any template at all. If it's the case that you have a single page and you want to communicate non-persistent user interface state across the templates, it's still really easy. Basically, you design your page as being a single kind of parent page level template with any number of component templates. The page level template will create a single reactive dictionary that it passes in to all of its component templates. And then those component templates, merrily get and set properties of that reactive dictionary to communicate whatever user interface information they need to tell anybody about. Everybody within that single page will now have access to that state and will be re-rendering themselves whenever that state gets updated due to the miraculous reactive nature of Meteor. But finally, there's one other case that I'm not talking that I'm only bring up in this particular slide. I didn't show it, but what about the case where you have user interface state that needs to be maintained across multiple pages? Okay, and that situation can get really hard depending upon how many levels of hierarchy it has and so forth. You could imagine simply creating a reactive dictionary at the level of the layout and passing that down to all of the components, and that would kind of work. But it can get error prone depending on how many levels you have. You could also think about using session variables, and sometimes that works. Those start to fall down when you can imagine an inspector that is instantiated 4 or 5 times. You're going to need a different session variable for each of them so that the inspector has different state depending upon where it is. That can get really bad. And then the final thing, is, and I'm just assuming this is true because of all the forum messages that I've read, is that when you get into that kind of situation where you're trying to pass state up and down the template hierarchy, apparently React is supposedly better than Blaze for this kind of purpose. So you might want to look at React in that case. All right, hope this helps. Thanks a lot.